Hello everybody, in this video we're going to be going through the solutions to the Arithmetic Progress Quiz number 1 questions. Let's go ahead and dive into it. So for each one of these we have to decide if it's rational or irrational. Remember, a rational number is something that can be written as a fraction. You can write 1 as a fraction, 1 over 1, so let's put a there. Negative 5.3, you can write that as negative 53 over 10, so that's a fraction. If you don't know why that results in negative 5.3, that's coming later in the study plan. Don't worry. 5 over 3 is already written in fraction form, so that's an irrational number. Now, the problem with this square root of 3, no matter what you do, you cannot write that as a fraction, so that's going to be irrational. And the same thing is true with pi. You probably remember pi, right? I don't mean Thanksgiving dinner pie. I mean the circle pi. That also cannot be written as a fraction. Some of you might say, well, what about 22 over 7? I know we're going back to junior high here, or high school. I apologize. Yes, this is true, but this is not pi. This is an approximation of pi. Okay, so remember the squiggly lines means close, but not exactly. So that's also going to be an irrational number. Let's go to number 2. So in this activity, we have to choose the category that is the most narrow. Remember, these categories are nested inside of each other. You can think of it as circles. The biggest circle is the real numbers. So because that's the biggest circle, it's not going to be narrow at all. So we can just get rid of that one. Inside the real numbers, you have the rational numbers and the irrational numbers. And I know that looks like a Ninja Turtle face. And then inside the rational numbers, you have the integers, and then you have the decimal numbers, you have the whole numbers, the natural numbers. You get the idea. Okay, so 3 is a natural number, a whole number, and an integer. Which one of those is the most narrow? It's going to be a natural number. Remember, those are just the counting numbers. Go back to caveman days, cave people days. 1, 2, 3, they had no idea what 0 was. All right, 0 is a whole number and an integer. The narrower category is going to be whole number, which is a. So this is just a rational number. It's not a whole number, it's not a natural number, it's not an integer. The best we can say is it's a number that can be written as a fraction, so that's going to be a rational number, which is d. A complex number, that's not on the GMAT. We can get rid of that choice too. This is going to be an irrational number. Notice the negative is outside of the square root sign, so that's okay. It's just a negative irrational number, so this is going to be e. This right here can be written as a fraction. Notice it's not a whole number, not a natural number, not an integer, but it is a rational number, so that's going to be d. And this one here with the 7 repeating, that's what that means. It just goes on forever. Believe it or not, this can be written as a fraction. So this is also a rational number. So the correct answer is going to be d. Okay, let's move on to number 3. So in this one, we are matching whether this is always true, can be true, but not always, or is never true. So p is an integer, but not a real number. This is never true. Every integer is a real number, so that doesn't work. P is a rational number and real. Every rational number is a real number, so that's always true. So that's A. P is an integer, but not a whole number. That can be true. So take, for example, negative 5. Negative 5 is not a whole number, but it's an integer. But take, for example, 5, that is an integer and a whole number. So that can be true, but not always. And then p is a real number, but not rational. Yeah, that can be true. Take, for example, the square root of 2. That's real, but not rational. But of course, p could also be 3, which is real and rational. So that's also going to be b, which is can be true, but not always. Number 4, which of the following can be included in a number line? Remember, a number line includes all the real numbers, all of them, even numbers that we can't imagine. Weird square roots and pi and all of these weird numbers, right? So all of these are going to be true. True, 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 true. Yeah, exactly. They're all true. All right, so easy enough, right? The following, now this one is kind of annoying. So we got to be careful. So we have to organize this on the number line. So what we want to do is draw a number line and just kind of work, with the information we're given. So the first piece of information we're given is that A is smaller than B. So if I put B right in the middle, I know A is going to be somewhere over here. Remember, when things are smaller, they're to the left. Okay. The next piece of information is that B is greater than D, but I don't know whether to put it here or here. So what do we know about A and D? Okay, we know that A is less than D. Okay, so that means I can put D right in the middle of them. What's the next piece? C is greater than E. I don't know where E is anywhere here, so let's ignore that for now. We know that B, 2B is less than C. Okay, so if 2B is less than C, then B is definitely less than C. So we can put C over here somewhere. And so the last thing we have to figure out is where is E? Okay, so we know A is less than D. Oh, A is greater than E. Ah, so that has to go here. And I think we have all 5, right? So the most right is C. So the rightmost goes with C. So that's A. I know that the letters are confusing. The second from right is B. So B gets a B. That's nice. The third from right is D. So D gets a C. The fourth from right is A. So that is going to be D. And then the fifth from right is going to be E. So E also gets an E. So the correct answer is D, B, A, C, E. I know it's a little bit confusing with the variables, but you get the idea. So whenever you're dealing with a number line problem, it's smart to draw the line out and just kind of work in a very methodical manner. Number 6, connect each digit. So this is about number places, right? So the 0, what position is that occupying? That's what we call the tenths with the TH, not the tens. Do you hear the Z sound? No, this is the tenths. It's a S, a Z versus a S. Z, 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 Z. So this is going to be the one with the S. So that is going to be C. All right, the 1 is in the ones place. That's convenient. The 2 is in the hundredths place. So that's going to be B. The 3 is in the thousands place, because again, 3,000, that makes sense, right? So that's going to be I. The 4 is in the hundreds place, hundreds with a Z. The 5 is in the, so this is where it gets a little bit confusing because the first one to the right of the decimal place is the tenths place, but the first one to the left of the decimal place is not the tens place, it's the ones or the unit place. So in this case, even though it's the third digit from the right, it's going to be the thousandths with the TH, so that's going to be A. And then number 6, that's in the tens place, which is going to be G. And if you look at this question, there's no such thing as the oneths place or the units place. That's kind of funny. But anyway, yeah, these are the answers. Number 7, numbers like 623.195, 0, blah, blah, blah. So they have this property where you're only using, remember, the system we use has 10 characters. So this is why we call it the decimal system. And you're going to learn more about this as you go through the plan. But the 10 characters are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now you might be going, what about 10? Well, 10 is just a combination of the 2 characters we've already said. So these are the 10 unique characters, and every other number is just a combination of these characters. So we have 10 characters. What is the largest number we can create where we use all of the characters but only once? Well, the largest number is you start with the largest number, which is 9, and then you go to 8, and then 7, and then you go to 6, and then 5, and then 4, and then 3, and then 2, and then 1, and then don't forget the 0, because remember, having a 0 at the end here versus not having it is like the difference between 10 and 1. 10 is obviously bigger than 1, so don't forget the 0. And then if we put our commas every 3 numbers, so what number is this? It's 9,876,543,210. That's the largest number we can create with this special property. Number 8, which 2 operations are described in the above phrases? So whenever you see minus or difference, that is subtraction. Whenever you see split or quotient, you're talking about division. So remember, you want to memorize that vocabulary, because on the GMAT, there's a lot of word problems. And a lot of times you have to translate the word problems into, do I put a plus? Do I put a minus? Do I put a multiply sign, a divide sign? So you want to memorize that kind of vocabulary. And then finally, number 9. So in this case, we just have to say true or false. And I think we mean true in every case. Because, for example, if you say A, B, and C are all 0, then yeah, that's true. But is it true in every case? No, this is not true in every case. Notice here, we're not multiplying the A times B, but here we are. So that's false. Now this right here, this basically says the order of addition doesn't matter, which is true. 5 plus 3 equals 3 plus 5. So this is true. So that's A. This is saying, again, that the order doesn't matter, but you have to be careful here because we're using negative signs now. So there's a couple of ways to think about this. You can think about this as A minus B minus C. That's one way to think about it. Another way to think about it is this is a positive A, this is a negative B, and this is a negative C. So if you come over here, again, we have a negative B, so that's the same thing. We have a negative C, so that's the same thing. And we have a positive A, so that's the same thing. So the order doesn't matter as long as you keep track of what's negative and what's positive. The one thing you have to be careful of is 5 minus 3 does not equal 3 minus 5. And you'll see why. Notice in the left side, this is a positive 5 and this is a negative 3. But over here, this is a positive 3 and a negative 5. But that's not what's going on here. We maintained everything, so this is true. This one is called the distributive property. The A goes into the 2 multiplied, and then the A goes into the B, which is exactly what's happening here, so that's true. Whenever you multiply something by 0, it's always 0, and you can't even divide by 0 anyway. We'll talk more about that later. So this is going to be false. This one here, whenever you multiply something by A or by 1, it's going to equal A, right? But when you multiply something by 0, it's going to equal 0. So what this really says is A plus 0 equals A, which is true. That's true. So this is A. This here, whenever you multiply anything by 0, it's going to cause everything to be 0. So this is false. Unless C equals 0 in this case, which we don't know. Remember, we mean true in every case, right? And then finally in this one, what is C plus a negative C? That's 0. What's a negative D plus a D? That's also 0. Does 0 equal 0? Indeed it does. So that is true. All right, I hope you guys enjoyed that, and I will see you in the next one.